Welcome. We're doing 9.1 here, and it's conditional probability. Conditional probability. And conditional probability means what's the probability given a certain condition or given a certain event. And they use an example here with TB testing, and they show a chart here that helps you to figure out some of the different probabilities. And the first question is, what are some observations? The first thing is you can tell from this first juncture here, what's the probability that a patient has TB? If you add the 380 plus the 620, you can see that there was conveniently 1,000 people who were tested. So out of 1,000, based on experimental results here, the probability of TB, which you could write as like that, is going to be 380 over 1,000, and you can represent that as 38%. And then you could write the probability of not having TB. There's some different ways you can write that, but that's what I'm going to say for now, is 620 out of 1,000, which is equal to 62%. Okay, and as these numbers get bigger and bigger, more and more people are testing, then these are going to be closer to the percent within the population. So that's just straight experimental probability, but there's some other things here. You'll notice of the people who have TB, when they tested them, some of them tested positive, 361, but there were some that even though they had it, they tested negative. So this part is what's called the conditional probability. All right. So, for example, we know that there's a 380 who have TB, and of those, 361 actually tested positive. So you could write this a little bit different. You could say, what's the probability that it's tested positive given that, so that's the important thing, given that they actually have TB. That's conditional. So given that they have TB, what's the probability that you test positive? You're only looking at those with TB to figure this out. And you can see of the 380, 361 would test positive. So the probability here at 0.95 is 95%. So if you have TB and you test positive, the probability that you're going to actually test positive is 95%. Whereas the probability of negative, test negative, given that, that's what that line is, they actually have TB, is going to be the rest of that, which is going to be 5%. Okay? Another one you could say is, if you don't have TB, you might actually get the results that you tested positive, right? So of the 620 who don't have it, 62 of those would test positive. So you could write that as the probability of testing positive given that you don't have TB is going to be 62 out of 620 conveniently, which is equal to 10%. So the thing is, you might test positive, but you might really not have it. That'll happen to 10% of those folks. So of 10% of the people who don't have it will actually end up testing positive. So that means 90% of the people who don't have it will test negative. And this is the result right here that we want, right? And this is the result that we want. Those are the two things. If they're positive, we want them to test positive. If they're negative, we want them to test negative. Okay, so that's some of the ways that I would interpret the data there. Conditional, so again, the way you write this conditional probability, I have it here, is this says what is the probability of this is what you're testing for, a testing condition or something like that. And this is, this symbol, if you remember, is given that. And this condition here exists. And then the probability is always a number from 0 to 1, right? And it's always that, right? So this is the probability that something happens given that we already know an event that happened. And this is going to be somewhere between 0 and 1. And so if I had a friend who came back as positive for TB, I would say, well, you know, it might be true, right? However, it's possible, for example, 62 out of 620, 10% of the people who don't have it actually test positive. So there's a chance that you don't actually have it. But I would probably move forward with the assumption that you probably do. Now, what would be interesting is to get some data, given the current COVID situation, on some of their positive and negative results. And I don't have that data, but that would be kind of a nice extension here.